Hello everyone, welcome back to another YouTube video here at Becoming a ROS Developer. Today what we're going to be doing is a presentation by one of our students, Shaharyar, who has completed the course we have online, which is ROS 2 Navigation in 5 days. And at the end of this course, you can take a project and implement it on a real robot. And you can present this project. So that's what we're going to be seeing here today from our students. So hello, Shaharyar, how are you?
Hi, hello. Nice to meet you.
Nice to see you too. So yes, whenever you want, you can start sharing your screen and just showing us what you've done with your project.
Yeah, okay. I will first present my work. I can't share my screen. It says that host disabled participant screen sharing.
Oh, let me make sure you can share it. All right, you should be able to now. Are you there? Hello, hello? It seems like we are having some connection issues, so let's give Shaharyar a couple of minutes here. Oh, I guess he disconnected. So let's give it a couple seconds, see if he can reconnect. Okay, I think he's
Hello.
back. Hello, hi.
Yeah, can
We
you see
missed
the
you.
screen? Oh, yeah, I think I got disconnected.
We cannot see your screen. We can see you so far.
Okay. Here. Now
All
can you see the
right,
screen?
now I can see your screen. Perfect.
Okay. So I have a presentation ready. This was the course, ROS 2 Navigation in 5 days. So the presentation outline is I will first of all give highlights regarding mapping, which was a unit in this course, then localization, path planning, obstacle avoidance, navigation, and in the end I will demonstrate the localization and navigation on real robot. So mapping is basically we generate a map of the environment. A map is basically a representation of the environment where the robot is operating. And the robots use map to localize themselves and to plan trajectories. Mapping is the process of generating map of the arena using laser scanner of the robot. And the robot we used is Turtlebot 3. And once the map is created, it is saved for the next sections. And we need 3 nodes to perform mapping, which are map server, AMCL, and lifecycle manager.
Okay.
This was the transforms tree which we generated in the mapping section.
Mm-hmm.
It basically shows relationships between different reference frames of the robot. And this was the map which I created for the simulation. And this was the map which was created in the ROS check. So coming towards localization, localization is when a robot transform between map frame and odometry frame. Localization, it basically means that the robot is able to localize it or identify its location inside the arena or the map in which it is moving around. So we need localization to spot the robot inside the map. And the main algorithm which was used in localization unit was adaptive Monte Carlo localization. It basically used particles to localize the robot, and all the particles have weights, and particles have their own coordinates and orientations. And bigger the weight of a particle means that it is more accurate, and it is defining the robot's pose accurately as compared to other particles. So this figure shows the uniform distribution of particles at this moment the robot was initialized, and we can see that the particles were uniformly, almost nearly uniformly distributed around the robot. And at this time, the robot didn't know that where it is properly located. So when the robot was moved around, the particles converged on the basis of the AMCL algorithm. Then we have path planning. Path planning involves planning a trajectory from point A to point B while avoiding obstacles en route. And we have 7 nodes required for path planning, which are nav2 map server node, nav2 AMCL node, planner node, controller node, recovery behaviors node, behavior tree navigator node, and lifecycle manager node. So the next unit was obstacle avoidance. In this unit, we added the obstacle avoidance feature in the robots. Global cost map parameters were added in the planner underscore server.yaml file. Similarly, local cost map parameters were added in the controller.yaml file, and obstacle layer was added. And another important point was that inflation layer must be present after the obstacle layer. Otherwise, the obstacles are not inflated, and the additional cushion for safety margin is not added. So these were the results in the navigation section, and I will come towards more detail in the demonstration.
Okay.
So yeah, in the navigation, we needed to navigate our robot to 3 different points. This is the first point, which is corner 1, and these are the details of the pose of robot at corner 1. The second spot is corner 2, and the third spot was pedestrian crossing. So now I will give the demo of the robot. I will give 2 demonstrations. The first is localization and the second is navigation. In the localization section, I will show that how we can manually get pose information from the AMCL underscore pose topic. And then I will demonstrate the service message which I created to record the different spots using a service. And then I will also demonstrate the saving of spots file, which includes the position and orientation details of the spots. And in navigation section, I will show the robot navigating to the desired spots using an action client.
Great.
Okay, so
Let's see it.
yeah. Okay, so these are 4 terminals. Here you can see that I am about to launch my launch file for localization, because I will give the localization demo first. This is command used to show the message of my service, custom message which I prepared. And so I will paste it, and when I will enter it, so here is my message being displayed. Request is based on string, and the variable is here label. And similarly, response is based on 2 variables, which is the Boolean, which shows the recording has been done or not done, true or false, and a string message which shows the details of the point which have been recorded.
Understood.
And okay, so yeah, our localization launch file has been launched. I will now launch the RWIS2. Here I will load the configuration which I saved.
Oh, love that.
I have a different configuration. Yeah, this one is the best. So yeah, here is the map which was created in the mapping section, and now I will first localize the robot,
Uh-huh.
and here we can see
Oh, nice.
the particles have appeared. So just to reduce the uncertainty, I will just rotate the robot
Yes,
first
rotating is
towards
the
right and
best.
left so that the error becomes reduced. Here we can see that the particles have converged.
Mm-hmm.
So the adaptive Monte Carlo localization algorithm has worked.
So now
Okay,
your robot is completely localized. It knows where it's at.
yes. And coming towards the service, I showed you how to show the service message. Now I will show the pose of robot using this command. So here we can see the pose of robot at
Mm-hmm.
the pedestrian stop here,
Nice.
position and orientation through the pose topic. Okay, so yeah, now I will demonstrate the service. I will call it so that it could save different spots. Okay, first of all, I will show you the service files. This spots underscore final is the file which I created, and it is the final one. And this is the one which will
Which
be
will do.
overwritten by
Uh-huh.
the robot now. So, okay. And yeah, I recorded 7 points,
Uh-huh.
which are starting point where the robot is right now. Corner 1 and corner 2 were given in the instructions. The
Uh-huh.
same one. This is corner 1, this is corner 2,
Uh-huh.
and corner 3 and corner 4. This is corner 3 and this is corner 4, and this pedestrian crossing has been labeled as pedestrian 2.
Pedestrian. Okay.
So if I call my service to record the
This
pose at
spot.
corner at starting point, I will press enter.
Oh, I think it's because you have two types of quotation marks in there.
Oh yeah,
Oh, yeah.
okay, let's move it to corner 1 first, and then I will record it. So here the robot is
Yeah,
at
here's
corner
that
1.
corner. Are you running your service server?
Yes. Just let me restart it. There are two packages basically. Number one is project localization and the other is custom services.
I see. But inside this launch, you have the
Yeah, I
service
have
server.
it. I have it. If I show you my launch file,
Ah, I see the
here
spot recorder. Okay. Yeah, yeah. Then
it was working
I know, I know.
previously.
See, spot recorder has died. I saw the a message. You see that error? Spot recorder has died.
Yeah.
That's strange.
Okay.
Maybe you can just run it on a separate terminal now. You know? So it died in this launch, so it's not running right now. So what you can
Yeah.
do is in another terminal, do ROS to run project localization spot recorder. Let's see if it's already compiled, so you wouldn't even need to do that.
ROS2
Run
run.
project localization. Should be able to find it if you tab. And then the name of your executable, which is going to be spot recorder or something. Does it autocomplete? Oh, look. It's yelling at you because there's not a module called pandas.
Oh yeah, I think I need to install it.
All right. So then
Pandas.
I
Yeah.
understand what you're
Just
trying to
let
do
me see.
here. You missed a library and that's why it's not recording, but I understand that this then you call the service and spits out the oh, you're installing it. That's nice.
Yeah,
That's quick.
just give me a minute. It will work fine.
You don't even have to rebuild or anything. It should just not die now.
Okay, let's see.
You see? Spot
Yeah.
recorder is not dead.
Okay, so here is the service.
Now you're not localized.
Oh yeah, sorry.
No, but
Look.
we should see that file
Yeah.
with there.
It is now
So
seeing the position
yeah.
000.
All
But
right.
it is not, since it is not localized, that's why it is
Of course,
showing
zero
this
zero
code.
zero. Yeah, yeah, yeah. So now if we see that file, we should see
Yeah.
one with 000.
Yeah, I need to
Oh, you
just
need to end
end
it,
it.
right? Uh-huh. So what by pressing end here,
It will save the file. And
ah,
here we can see.
there it is. Awesome. Wow, that's so cool. Great.
Okay. So I think to save the time, let's go to the next
Yeah, so you can localize it
section.
and then maybe send it to some of those spots you just showed us. So you'll probably have Arvis in that second. Oh, okay. That's fine.
Yeah, I have the commands.
Ah, nice.
This is the navigation file, which is launching the all the nodes required for
The
navigation.
path planning. But you killed navigation localization again. And this is your client that takes in those spots and sends them over to nav2 stack.
Yes.
But this will not work because you need to launch your localization as well. Right?
Localization launch node, I think, is is included in the navigation
Oh,
prompts.
great. Awesome.
Okay, so here it is now asking for label. Let me see whether the robot is localized properly.
It's in that corner. I never actually localize them. I just trust the nav2 stack.
It gets confused, no?
Yeah, but sometimes it finds it.
So I will just first do this.
You might have to give it a nudge.
Yeah, it's getting in place. Okay, so let's go. If I enter now label here, so in this file, the final one which I prepared,
Uh-huh.
we have 7 points. Any of these labels will work. For example, if I give it pedestrian,
Uh-huh. You tell it, where do you want to go?
it will go here.
Uh-huh.
So if I press enter, so we can see that the robot has started moving
Ah,
to this point.
awesome. That's great. So, and if
And
you
if
do
I,
another one, same thing, right?
yeah, for corner 2,
Ah, that's great.
it will move here
Uh,
and on the corner 2.
this looks very configured as well. It doesn't
Yeah,
get lost. It doesn't replan or anything, which is common in these things. Awesome.
yeah,
Awesome, Shaharyar. Well, this is amazing. And you can do another corner. All right.
yeah.
That's nice. That's really nice, Shaharyar. Very nice project. Yeah. All right. So let me kind of summarize here what Shaharyar did. So first, he created a program to localize the robot. He used AMCL and nav2 stack. All right.
Yes,
Then what you did was create a program that uses this localization in order to save some spots where the robot is. That way you can remember instead of coordinates, right? And then you have a client for the nav2 stack that takes in those strings, then looks up at that table of coordinates, and is able to then send it to the nav2 stack, and it goes there. So this is an application, a simple application on top of nav2. So Shaharyar, I want to congratulate you. Very nice, very straightforward. I love the
thank you very
fact
much.
that even when pressed with time, you were able to know what was going on and redo things. I even told you don't install Panda, we'll do it without it, and you did it right away, which means
Yeah,
you've been you know, kind of fighting with this project.
yeah.
So I want to congratulate you. Really nice,
Thank you.
really straightforward, and you understood all the concepts that for AMCL. The only one thing that I wanted to mention is that remember that every time you talk about the localization and you talk about, well, this is the pose of the robot, it's going to be with respect to something. And in
Yeah,
these cases, this is where, when you start mapping, that's where the publish transform between map and autumn is published. So that's
yeah,
going to be your 000. So it's actually kind of
exactly.
important to, well, not very important, but it matters where you start mapping because that will be your 000. So I just wanted to make that comment in case because it's important to know that if you start mapping somewhere else, well, your coordinates are gonna be different. But I mean, other than that, Shahriyar, that was very clear, very straightforward, and I just wanted to congratulate you again.
Thank you.
Very
Thank you.
nice. All right.
Thank you so much.
Awesome. Well, yeah, that's it for us, guys. Quick and simple with a great application of nav2 that here Shahriyar showed us. showed us of his project with the ROS2 navigation. So I invite everyone else that is watching to do the same, to show us here, to come and show us what you've done with your nav2 stack and how it works on an actual robot after taking our course. So thank you again one more time, Shaharyar, and I hope to see you around next time.
Thank you. Sure. Thank you. Thank you so much.
All right. Bye-bye, everyone.
Bye-bye.
We'll